A synthetic unit hydrograph is that derived using an established formula without the need for rainfall runoff data analysis. The volume of a unit hydrograph is equal to the catchment area multiplied by 1 unit of runoff depth, either 1 centimeter or 1 inch. Since the volume is known, the peak can be calculated by assuming the shape of the unit hydrograph. For instance, if a triangular shape is assumed for simplicity, with peak Q sub P in triangular time base T sub BT, from this equivalence, the peak flow is obtained. Synthetic unit hydrographs relate time base to catchment lag. In turn, catchment lag is related to the response characteristics of the catchment, including shape, length, and slope. 2 synthetic unit hydrographs are in common use in the United States. 1. Snyder, and 2. Natural Resources Conservation Service, or NRCS. In 1938, Snyder introduced the concept of synthetic unit hydrograph. The analysis of a large number of hydrographs from catchments in the U.S. Appalachian region led to the following empirical formula. In which T sub L is catchment lag, L is hydraulic length, L sub C is the length measured along mainstream from the outlet to a point closest to the catchment centroid, and C sub T is a coefficient accounting for catchment gradient and associated storage. With L and L sub C in kilometers, C sub T varies in the range 1.35 to 1.65. With L and L sub C in miles, C sub T varies in the range 1.8 to 2.2. Snyder's formula for peak flow is C sub P is an empirical coefficient related to the ratio of triangular time base to catchment lag as follows. Snyder gave values of C sub P in the range 0.56 to 0.69, which are associated with T sub BT over T sub L ratios in the range 3.57 to 2.9. In SI units, the Snyder peak flow formula is in which Q sub P is the peak flow for 1 centimeter of runoff in cubic meters per second. A is the catchment area in square kilometers, and T sub L is the lag in hours. In U.S. customary units, the Snyder formula is in which Q sub P is the peak flow for 1 inch of runoff in cubic feet per second. A is the catchment area in square miles, and T sub L is the lag in hours. In Snyder's method, the unit hydrograph duration is a fraction of the lag. The unit hydrograph time to peak is equal to 1/2 of the storm duration plus the lag. Therefore, Snyder included inner flow as part of direct runoff. This led to a somewhat longer time base. The formula for time base is in which T sub B and T sub L are in hours. The Snyder method gives peak flow, time to peak, and time base. These values can be used to sketch the unit hydrograph, adhering to the requirement that unit hydrograph volume must be equal to 1 unit of runoff depth. The parameter C sub t is a function of catchment slope. The dimensionless parameter C sub p is a function of the runoff diffusion characteristics of the catchment. The maximum value of C sub p occurs in the absence of runoff diffusion. In this case, C sub p is equal to 11/12. The Snyder method is a two-parameter model, generally applicable for mid-sized catchments in the upper range, say around 1,000 square kilometers or 400 square miles. It is extensively used in U.S. Army Corps of Engineers practice. The NRCS synthetic unit hydrograph is the dimensionless unit hydrograph developed by Victor Marcus in the 1950s. The method fixes the ratio of triangular time base to time to peak to a constant value of 8/3. This implies that in the NRCS unit hydrograph, the Snyder parameter C sub p is constant and equal to 11/16. This stresses the applicability of the NRCS unit hydrograph to the lower range mid-sized basins, say from 1 to 100 square miles. Unlike the Snyder method, the NRCS method specifies a constant ratio of actual time base to time to peak equal to 5. In addition, it specifies a dimensionless unit hydrograph to provide a standard unit hydrograph shape. To calculate catchment lag, that is the T2 lag, the method uses the curve number method or the velocity method. The curve number method is used for catchments less than 2,000 acres or 8 square kilometers. The velocity method is used for larger catchments. In the curve number method, the lag is calculated based on catchment length, slope, and curve number. In the velocity method, the lag is estimated at 60% of the time of concentration. The ratio of time to peak to unit hydrograph duration is fixed at 5. The ratio of time to peak to catchment lag is 10/9. The ratio of unit hydrograph duration to catchment lag is 2/9. The ratio of unit hydrograph duration to time of concentration is 2/15. The unit hydrograph peak flow formula is in SI units. The peak flow formula is in which Q sub P is the unit hydrograph peak flow for 1 centimeter of effective rainfall in cubic meters per second. A is the catchment area in square kilometers, and T sub P is the time to peak in hours. In U.S. customary units, the peak flow formula is in which Q sub P is the unit hydrograph peak flow for 1 inch of effective rainfall in cubic feet per second. A is the catchment area in square miles, and T sub P is the time to peak in hours. The NRCS method provides a unit hydrograph shape and therefore leads to more reproducible results than the Snyder method. However, the ratio of triangular time base to time to peak is fixed at 8/3. This renders the method inflexible in certain cases. In particular, values of triangular time base to time to peak other than 8/3 may lead to other shapes of unit hydrographs. Values larger than 8/3 imply greater runoff diffusion in catchment storage. Therefore, since the NRCS method fixes the value of triangular time base to time to peak at 8/3, it should be limited to mid-sized catchments in the lower range of the spectrum, from 1 to 100 square miles, or 2.5 to 250 square kilometers. The Snyder method can be used with larger values of triangular time base to time to peak, meaning greater runoff diffusion in catchment storage. Thus, the applicability of the Snyder unit hydrograph is extended to mid-sized catchments in the upper end of the spectrum, from 100 square miles to 2,000 square miles. That is, from 250 to 5,000 square kilometers. The number 2.08 in SI units and its equivalent 484 in U.S. customary units is known as the peak rate factor of the NRCS unit hydrograph. It is the standard peak rate factor associated with triangular time base over time to peak equal to 8/3. If data warrants it, greater values of triangular time base over time to peak can be considered, which lead to smaller values of peak rate factor. These non-standard values of peak rate factor are applicable to unusually mild basins where low relief can be responsible for substantial amounts of runoff diffusion.